Okay, so this is 11C on specimen paper 1, and they said using the substitution t equals tan theta, find the value of the integral from 0 to pi over 4 of d theta over 3 cosine squared theta plus sine squared theta. So this is at least more typical because they gave me the substitution. Generally, y'all don't like it if they use t's. You can do good games rule, do x's if you really want to, or use substitution. But generally speaking, I'm just going to stick with whatever they give me. Okay, so when you do t, you're also going to need to have an expression for d theta. So you're going to need to take the derivative of this. Okay, so all of this was given, and I'm just going to put that away. And we'll go ahead and take the derivative of this. So do you happen to remember what the derivative of tangent is? Secant squared. So secant squared theta d theta. That's what we've got formula sheets for. Okay, so basically I'm going to try to change this problem so it's got all t's and no thetas. Now again, I have that choice, but time's an issue. These are theta values. Okay, I am going to choose to not have to go back to thetas at the end of all this. And I'm going to go ahead and change these to t's. Okay, so let me go ahead and do that first. So t is tangent theta. So I can just put in this theta, and it's a direct solve. Okay, so t would be the tangent of pi over 4. And anybody know the tangent of pi over 4? Oh, come on. Tangent of pi over 4. What are the coordinates at pi over 4? It's the easiest one. Yeah, tangent's 1. That's right, because it's square root 2 over 2, square root 2 over 2. So when you do sine over cosine, you get 1. So that's my favorite tangent for them to ask. I don't really like it when they ask the ones with the square roots of 3 in it, because I got to figure out if it's pi over 6 or pi over 3. And that's a pain in the patootie. So this is 1. Okay, and then the tangent of 0, because that's my other bound. And what's the tangent of 0? There you go. Okay, so when I change these bounds, they're going to be from 0 to 1. Okay, now I have to put it in, substitute in for all these things with theta in it. So for d theta, I've got to solve this for d theta. So if I get d theta by itself, it would be dt over secant squared. Does that make sense? Yes, no, maybe? I'm saying if you take this guy, it'd be dt over secant squared theta would give you d theta. Okay, so I'm going to put that in. Now I really haven't done exactly everything I'm supposed to do yet because I still have a theta in this. Okay, but I'll take care of it in a minute. Okay, and then for these, I need to put in for cosine and for sine. So I'm going to need to draw my triangle. Okay, so they said the tangent of theta is t. So if you make your triangle so that your angle is theta, the tangent of it's t. So tangent is a ratio of opposite over adjacent. Okay, so opposite would be t and adjacent would be 1. You're doing it like it's t over 1. And then you can Pythag to find the last side. So this would be the square root of 1 plus t squared. Okay, and then you put in just the cosine of the angle, which is adjacent over hypotenuse. So 1 over the square root of 1 plus t squared, and that's squared. And then plus, you're going to do the sine of theta, and you're going to square that. So sine is opposite over hypotenuse, so t over the square root of 1 plus t squared. And that's squared. So I've almost changed this into all t's. I'm going to have to simplify these guys, and I need to change that secant squared theta. Okay, but cosine is adjacent over hypotenuse, so secant would be hypotenuse over adjacent. Oh, but you know what? You want to just make this dt over secant squared? We could just make that cosine squared dt. Do you want to do that? Yeah, because 1 over secant squared is cosine squared, so that might just be easier to think about that. I almost want to put an arrow for all this stuff. We could simplify it a little bit since we have to write it again anyways. When you square it, it just takes the square root off, so we'll at least do that. And on this one, you'd have t squared over 1 plus t squared. Okay. Believe it or not, we're making progress. Okay, so from 0 to 1, for cosine now, we can just do cosine is adjacent over hypotenuse, so 1 over the square root of 1 plus t squared. 1 over the square root of 1 plus t squared, and we're squaring that. Okay, and I have a common denominator already in the denominator. In the denominator, I have a common denominator, okay, because we have a fraction in the denominator of this fraction. So you could leave 1 plus t squared, and this would just be 3 plus t squared going across the top. Is that okay? Okay, so when I rewrite this, if I square everything, it'd be 1 over 1 plus t squared. And then this is one great big divide. So it's divided by this, so I'm just going to change it to times the reciprocal. Life's about to get a lot better. Okay, so these guys will cancel. And now would be a good time to start looking at the formula sheets. And see if you remember what that guy is. Okay, so it is arctan. Good. It's this guy right here. Okay, so I'm just going to kind of write the formula there so we'll have it close by to look at. 1 over a squared plus x squared dx. And it's 1 over a arctan x over a plus c. Of course, we're not going to need the plus c because it's a definite integral. All right. Now, I do think the specimen paper, they made it particularly long, partially because they wanted to show every type of problem that could happen in the change in the syllabus. But for us in this problem, what's a? Perfect. A is square root of 3. Okay, so when I integrate this, I would have 1 over the square root of 3 arctan. What I have in place of x is just t, so t over the square root of 3. And I don't need the plus c, I just need to evaluate it from 0 to 1. So I'm going to have 1, oops, screwed up, 1 over the square root of 3 arctan of 1 over the square root of 3 minus 1 over the square root of 3 arctan 0 over square root of 3. And the good news is the arctan of 0 is 0, so that guy is gonzo. And the question is, which angle has a tangent of 1 over the square root of 3? And you can, if you want, just use 30, 60, 90 because it has to be 30 or 60. It is 30, good. So we can, and of course we're going to use 5 or 6, but so you could do the 1 square root of 3 and 2, and you could just say opposite over adjacent for the 30 is 1 over square root of 3 if you don't want to deal with the unit circle. Okay, and so then you got this guy. And so your answer is just pi over 6 square roots of 3.